Okay, in this video, we are going to be looking at section 8.7 for Chem 1151. In this section, we're going to be discussing dilutions. And so in the last bit, we talked about concentration and how we can measure differences in concentrations. But what if you have a solution and has a certain concentration, but you in your reaction or in your work, you need it to be a lower concentration. It's too concentrated. So for example, when we're in the stock room of like a chemistry lab or a university and for like our labs, we don't want to store every possible dilution of a thing. We store a chemical in really concentrated amounts, and then someone working in the stock room will dilute what we need for the lab. Because, for example, I don't want to have y'all working in the lab with an acid that is so concentrated that it could really hurt you if it got on your skin. Because as first year chemistry students, you might spill something. And I don't want what you spill to be so dangerous that it could burn through your skin or burn through your bone or anything like that, like some very concentrated acids can do. So the stockroom will not let us use the really, really concentrated scary stuff. They will take the really concentrated scary stuff and they will dilute it down into less concentrated versions so we can use those versions for our labs. So what is dilution? Dilution is the process by which we decrease the concentration, and we do that by adding solvent. So let's say you made yourself some coffee and it wasn't made with enough water and it is very concentrated. Or, if you buy like prepackaged iced coffee, for example, you know that a lot of it is concentrated and you should like drinking one container of that is not the same as drinking a container. That's like it's like 200 coffees or something in that one bottle, right? Or 20 coffees in that one bottle. So what you do is you pour a little bit of it out and then you add water on top of that. You just did a dilution. And the company has already done math to help you figure out how much of the concentrated coffee you should put into your cup and how much water you should add to make it the right taste. And so you can look at the instructions. It'll probably say like add this amount to this amount, add this amount of coffee to this amount of water to get your desire. I mean, of course, you can make it more concentrated or less concentrated depending on your liking. But if you're like, well, how much do I add for a single serving? They will have that information in the instructions for you. So they've done this math for us. However, in the lab, we're going to have to do our math ourselves. So there's a formula that allows us to quickly look at what the new concentrations, old concentrations, new volumes, and old volumes will be. This is the dilution formula. M1V1 equals M2V2. And it looks a lot like a gas law formula, right? So the way we use it is exactly the same as a gas law. We're just going to plug in our values and solve for other values. The ones are your initial values. This is usually going to be your stock solution. So whatever is the more concentrated one, the final values are going to be your less concentrated one. So it will have a larger volume. So the V2 is usually higher than the V1. So for example, let's say this was 50 milliliters and then this was 75 milliliters. But I want you to look at the number of moles of the solute hasn't changed. So if I had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 moles of solute in my 50 milliliters, I still have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just now it's in 75 milliliters. I've diluted it. So the moles, this is maybe an important note to make. The moles or amount of solute particles does not change. You can add water all day, but the amount of salt, NaCl you have in a salt water sample will be the same. So if I put a bunch of salt into some water and then I keep adding water, I'm not taking out salt by adding water, right? I'm just adding water. I'm making it less concentrated. But when you do the coffee example, right? You put in a little bit of your coffee, you're not taking out caffeine. You're not taking out the coffee molecules, the things that make the coffee, the different things that make the flavors. You're just adding water. So we don't remove moles, we don't remove molecules, we just add water to make it less concentrated. So here's an example. I mean, I'm hoping that after gas laws, this will be relatively easy for you. But this is an example. Let's say if we want to go from 5 milliliters of a 3.2 glucose solution and we want to dilute it to 40 milliliters, what will be the new concentration? And so we have our first molarity is 3.2. Our first volume is 5.0. Now you need to know who goes with what. See how this says of A here? Of A or of a. This is these are connectors. So that means that if this one is your 1, this is also a 1. If 5 is a 2, 3.2 is also a 2. So this is my V1, this would be my M1. If this is my V2, this would be my M2. These two go together because of these connecting words. So we cannot just read the numbers in the order in which they're written. In this case, that's a 1, that's a 1, that's a 2. But however, I could have given you this information first, and I could have said, I'm making a solution of 40 milliliters. What concentration would it be if I started with 5 milliliters and 3.2 molar? So, just because the order of what we're reading doesn't make which ones are ones and twos, which partners we have. It's the words that describe, you really need to read for understanding to describe what molarity goes with what volume. Then if we're just solving with M2, so what we'll do, and go ahead and try this if you haven't already, but pause and try it. We're going to rearrange our variables just like we did for gas laws so that we have M2 equals, and then we're just going to plug our numbers in. We got to make sure for a couple things our volumes are the same. So for example, if this was liters, we'd have to change it to milliliters or vice versa. And then you make sure that your concentrations are the same. You could actually use this formula for any concentration. We could use ppm, we could use percent weight volume, percent volume, molarity. This formula won't change. I know it's M in the formula because it's dealing with molarity, but you could put in C here and talk about any concentration unit as long as it's the same on both sides. And so looking at this problem, we would just plug in. Notice that our units are going to cancel the way we want, and then we'll get an answer. Easy peasy.